Hey guys, in this video, we're going to be taking a look at adding the Bondtech LGX Lite extruder onto the Creality CR-10 Smart to upgrade it to a direct drive extruder. Now in a previous video, I did an all metal hot end upgrade on the same printer, and those parts were from Micro Swiss and they were intended for a Creality CR6-SE. Now the CR-10 Smart and the CR6-SE are very similar printers with a lot of interchangeable parts. And so I'm going to assume that this upgrade should also work on the CR6-SE with no modifications or very few at least. And if one of you guys has a CR6-SE and happens to do this upgrade, please confirm in the comment section down below my suspicions of needing very little changes to this whole procedure to make it work on the CR6-SE. All of the 3D printable parts and files that you're going to need for this conversion can be found in the video description down below. I'll put a link down there. And if you guys are interested in seeing the all metal hot end upgrade that I did on the CR-10 Smart, the link will be in the top right hand corner of the screen right now to my previous video. Now, the reason that I also chose the Bondtech LGX Lite for this conversion is that it's a very small and compact solution. It has a very small stepper motor on there, a pancake style stepper motor. It uses a gear reduction, so you still get a lot of torque, but with very low mass. And so I'm hoping with the low mass of this extruder, I'm not going to get things like ringing or ghosting that would normally be associated with a large mass moving back and forth very quickly on the printhead. So let's take a look at what's required here to install this thing, and we'll get started right away. And so the first thing we're going to do here is open up our LGX Lite extruder kit from Bondtech and see what's inside. And you're going to notice that there is an extruder inside and not a whole lot else, because that's pretty much what you paid for. And there are two options though for this kit, and one of them comes with the motor, which is what you want. And there's an option to buy this extruder without a motor, which is what you don't want if you're planning to do this. The 3D printed file that you see there can be found in the video description down below. That's going to be the mount to mount this LGX Lite extruder to the CR-10 Smart. I've designed this and I've supplied the files. Like I said, you can find them down in the video description down below. Once you get the LGX Lite extruder out and into your hands, you'll notice there are two socket head cap screws in the front. You can just simply unscrew those, remove the motor from the back, and you're going to remove this intermediate plate. The mount that you printed is going to replace this plate, and it should fit exactly into place, and the motor should fit into the recess that is designed into the mount. Now you might have to do a little bit of wiggling around, just like I'm doing here, because the teeth of the motor are going to have to engage with the teeth inside of the gear set. And once you get everything aligned, the socket head cap screws should slip back in, pass through the holes, and thread back into the motor itself to sandwich everything together, and then you have your motor and your mount as one nice solid piece. Next, we're going to be mounting the strain relief to the main body, and we're going to be using the two holes on the front. And those two holes correspond with the centers of the two hex cutouts in the back as part of that hex pattern. And so that hex pattern is actually meant to hold two of these nylock locking nuts. So these are M3 nylock locking nuts. And you'll notice there that I also have M3 socket head cap screws, and these are 10 millimeters long. So you're going to need two of those. And they're going to pass through the strain relief. They're going to pass through the holes in the main body. And then they're going to, of course, thread into those nylock locking nuts. And the hex pattern on the back of this piece should hold them in place while you tighten them down. And once you have two of them tightened down, then the strain relief is fixed into place. Now we can head over to our printer and start working on that. And the first thing we're going to do is remove the fan shroud cover off our hot end. And there are three button head cap screws to do that, two in the front, one in the back. Simply just remove them and the fan cover will fall off. Now you'll notice on mine that I've already done the all metal hot end swap, and so my Bowden tube adapter here looks different than yours if you haven't done that all metal hot end yet. The original one from the printer is black, and it connects to the two button heads there that connect the strain gauge sensor to the X carriage. And so in any case, it doesn't matter which one you have, just remove the Bowden tube and put it aside. You should now have fairly unobstructed access to the two large button head cap screws that are holding your V-wheels on to the X carriage assembly. And you're going to need to remove these V-wheels, so simply just unscrew those screws and the nylon locking nuts on the back will come off. The whole assembly will tilt forward and it'll be hanging by the belt, which is okay for a few minutes. We will not be reusing the aluminum spacers that sit between the V-wheels and the X carriage, so you can save them, but you don't need to reuse them for this new extruder. Next, you're going to cut your piece of PTFE tube that's going to go between the extruder and the hot end. And in my case, with the all-metal hot end, it's only 45 millimeters long. If you have the original hot end, where it is not an all-metal hot end, and that piece of PTFE tube goes all the way down to your nozzle, it is going to be longer. The exact dimension, I don't know, because I developed this kit with the all-metal hot end, so you're going to have to do a little bit of trial and error to figure it out. Once you do figure it out, you will be mounting your extruder here onto the carriage. So you'll see how I'm slipping the mount over top of those bolts that originally held the V-wheels. While I'm doing that, there's still a little bit of wiggle room in there, and you can wiggle that piece of PTFE tube into the recess that accepts the PTFE tube on the bottom of the extruder. And then you can take your V-wheels and you can slide them in the back, and you're going to use the original nylon locking nuts to lock those wheels in place. So as I had mentioned in the previous clip, you're not going to be reusing the aluminum spacers because they're built into the extruder mount that I designed and that you've printed to get the extruder onto the X carriage here. One thing to take note of here as I'm tightening these bolts down is that I did not reuse the brass compression fitting on the all-metal hot end. So that PTFE tube that sits between the extruder and the hot end, there is no compression fitting. You'll notice earlier in this video I removed it, and that was securing the Bowden tube in place, and it was fine while it was a Bowden tube. But now you want a little bit of wiggle room or movement between the hot end and the extruder, because this machine uses the strain gauge sensor to do the auto bed leveling. And so if you have the original Creality hot end, maybe don't put the retaining clip inside of the push lock fitting, because again, you want a little bit of wiggle room in there so that the strain gauge sensor can still operate and trigger when it touches the print bed. Now that we have the extruder mounted, we have to make the electrical connections, and we're going to be wiring it into the circuit board located inside of this cover here on the X-axis. So we need to take a flathead screwdriver, pry away at the top of the cover and at the bottom of the cover until it pops loose, and then you're going to be able to wiggle it off just enough to access the circuit board inside. It won't come completely off because there's going to be a lot of connections still made, and you're going to find that it's not worth removing all those connections, but you're going to be able to get it off enough that you can see the circuit board inside and all of the connectors. And so the only connections that I found that were worth disconnecting were the filament runout detection sensor, which you see me disconnecting up here, and now the extruder motor, the existing extruder motor connection, which we're going to be removing anyways. And by removing those two, you should have enough room to now wiggle that cover loose and gain more access to the connections on the inside. And that extruder motor connection, we're going to be completely removing that anyways. Once you trace the other end back to the PCB here, we're not going to be reusing that little piece of wiring, and so you can get rid of that completely. Once inside the panel, you're also going to find a little zip tie on the wire sheathing that traces back to the hot end wire bundle, and you're going to want to cut that off. And with the zip tie cut, you can pull the wire sheathing back a little bit, and this is going to give you some room to fish the new extruder cable through, and of course it's going to come out this opening here. Looking closer inside of the panel, you can see the empty connection slot second from the bottom that I was just pointing to, and that was where the original extruder plugged into. And I removed that connection, and I removed that little piece of wiring that went from this slot to the extruder, and I didn't capture that on video because it's such a small space to work within. I couldn't get a clear shot, my hands were always in the way, but you're going to want to remove that. I've then fished the new extruder cable through the wire sheathing, and obviously it comes out the other end. It will fit. The wire sheathing is expandable, so you should be able to get the plug through without depinning it. But before plugging it back into that extruder slot that's now empty, you're going to need to swap 2 of the pins. And the reason for that is that the way it is currently wired, the extruder motor will run backwards. And obviously that's not good. We want it to run forwards. So to do that, we need to swap 2 of the wires on the same coil. So right from the motor diagram, right from the Bondtech website, you can see that the yellow and blue wire belong to the same coil. So we need to swap those 2 wires on the connector. If you've never done this before, it's a pretty simple process. You can pretty much just use a hobby knife or a razor blade and depress the little terminal pins and get those wires to push out of the connector and then push them back in. I'll put a link in the video description, and there's a video right from Bondtech and they explain how to do this. So I'm not going to bother showing it in this video. You can visit that link. Once you get them swapped over, it's going to look something like this. So looking at it from left to right, you got red, green, blue, yellow. And this should get your extruder moving in the right direction. With the connector repinned and plugged into that connector board, we can come back to the extruder side and start cleaning up some of the wiring. So I'm going to take that excess wiring from the extruder, I'm going to tuck it in behind the wire sheathing inside of the strain relief piece, and we're going to take a zip tie. It just pushes straight through that channel and comes out the other side, and we can tighten down that zip tie. There's going to be a little bit of extra slack in the wiring that I tucked down to the bottom there, where you see me pulling on it right there, and that is going to be hidden inside of the fan shroud. And speaking of the fan shroud, we're going to install that right now, but before doing that, I'm going to show you that I cut away a small portion of the top left hand corner of this fan shroud just using a Dremel tool. That's going to provide a bit more room for the wire bundle up here, and that's going to keep it from having to bend at a very tight radius. You could probably get away with not cutting the fan shroud, but cutting it reduces the amount of stress on those wires having to bend into the fan shroud cover and into the hot end, and that's always a good thing. The rest of the fan shroud cover will install with the original 3 button head cap screws, 2 in the front and 1 in the back. On the connector panel side, I pulled through all of the excess wiring of the extruder motor harness and bundled it up nicely with a rubber band, and that should fit inside of that panel when we're done. All of the connectors, I put hot glue back on them. There was hot glue on them from the factory to begin with, and in order to unplug the extruder motor connector, the original one, I had to remove some of that hot glue, and so I just used a regular hot glue gun to put more hot glue back on to keep those connectors from working themselves loose in the future. With the connector panel cover snapped back on and the filament runout detection sensor plugged back in, we can now work on removing the original extruder equipment. There are 3 screws accessible from the top of the extruder arm mechanism, and you can simply unscrew those and the whole thing will come apart. Keep in mind that there's a spring inside, and as you unscrew and loosen those screws, you may notice the arm and a few of these parts start to move around and contort a little bit under the pressure of the spring. Eventually, when the screws finally come loose, things might explode and end up everywhere. So keep your hand around the whole mechanism and try to minimize the amount of parts that you lose in case you ever want to go back to this thing. With the extruder arm mechanism removed, you can now remove the original Bowden tube from the push lock fitting, and there are also 3 more screws visible from the top that are holding the stepper motor to the bracket. So again, just simply unscrewing those will remove the stepper motor. Keep in mind that the stepper motor is fairly heavy and there's a glass plate underneath. So as you're removing these bolts, put your hand under the stepper motor because it will fall down and it will crack your glass plate if you don't catch it. What you'll be left with is an empty bracket on which we will install a new filament guide that I designed for you guys, and we'll get to that now. And so the first thing you're going to do is grab your extruder motor, and we're going to reuse the push lock fitting. If this push lock fitting is damaged or lost, keep in mind that your printer came with a few extras and they're likely going to still be in that front drawer of the printer. But if yours is okay, then you're going to take this one and you're going to insert it into the new filament guide on this side of it. It might be a slightly tight fit, so you're going to have to manipulate those little prongs or tabs, whatever you want to call them, in order to get it to squeeze into there. But once it's in there, it should operate in the exact same fashion as it did when it was on your extruder motor. Then you're going to need 3 M3 by 10 millimeter long socket head cap screws, along with 3 M3 nylock locking nuts. And you're going to take that whole assembly now, and you're going to put it onto the empty bracket where the stepper motor used to be in this particular orientation here. You're going to drop in the 3 M3 by 10 millimeter socket head cap screws. You're going to put the nuts on the bottom, but you're not going to fully tighten them down just yet. And the reason for that is that we are going to get this thing aligned properly with a piece of filament and your filament tube, such that when it's time to load and unload filament, it's an easy process where the holes are lined up with one another, because sometimes I know it can be very frustrating to feed in new filament when the tip of the filament is not passing through the holes. So using that original clear filament guide, we can slip that back in place in between the filament runout detection sensor and the new tube guide. You can take some spare filament and your Bowden tube, your original Bowden tube, and you can get the thing aligned. So push the piece of filament in and it'll pass through the runout detection sensor. It'll pass through the original clear filament guide into the new one and into the tube. That's going to hold a nice alignment, and then now you can tighten down those M3 socket head cap screws with the nylock locking nuts, and you're going to have a perfect alignment between all of those holes. If you guys are still with me up until this point, thanks for sticking around. As you can see, I put a lot of time and effort into these videos, and I would really appreciate it if you guys dropped a like on this video or subscribe to my channel. It's just a friendly reminder because it does provide me with a lot of encouragement to continue doing this sort of thing. And so back into this installation here, you can see that now I have the printer flipped onto its side and I'm removing the bottom panel, because what we need to do next is we need to adjust the reference voltage on the stepper motor driver to reduce the current going to the new smaller pancake motor. And so there are a bunch of small M3 screws that you're going to have to remove on the bottom of the printer. And once you have them removed, you're going to slowly take that panel off. Don't rip it right off because there is a fan attached, and you can see the fan wire still attached to the main control board, and that should simply just pull off of the main control board, and now you can put the panel down safely. Once inside the panel, the main board is easily accessible and clearly visible. On the far left-hand side of the board, you'll see the leftmost heatsink, and that's covering the extruder stepper driver, and that is a TMC 2208 stepper driver. I'm quite certain of it. And there are equations online to figure out what reference voltage you need in order to produce a specific output current. And the pancake motor on the Bondtech LGX Lite is limited to about 0.65 amps. And so I found the equation, I did the math for you, and you should have to adjust this reference voltage using the trim pot to approximately 0.58 volts or so. And that will produce the correct amount of current such that your stepper motor does not overheat. Obviously, you're going to put the bottom panel back on, and once that's installed, you can flip the printer back up upright, turn the machine on, and we're going to test out the auto leveling process to make sure that anything we did on the hot end and extruder did not negatively affect its ability to auto level again. I had absolutely no issues after doing the direct drive installation with the auto bed leveling procedure, and so that tells me whatever modifications were done around the hot end, it did not interfere with the strain gauge sensor, and everything appears to be working normally. One of the final things we need to do here is to change the Esteps value in the firmware, and there's a few different ways you can go about doing this. One of them is through a terminal window, and so I'm using Octoprint to do this, and we can type in M503, and that's going to report back all of the settings from this printer, and we can look at the M92 line to see the factory Esteps value. And so it is E93, so that's 93 steps per millimeter from the factory. We need to change that. So to change that, we're going to type in M92, and then we're going to type in E562, and 562 is the value from the Bondtech website, so it's 562 steps per millimeter for the LGX Lite. You're going to hit enter, and then you're going to need to type in M500 to save those values. So you can see that it received it. Then, like I said, M500, that's going to save and write those values to the memory. And then you can type back in M503 and make sure it reports back on the M92 line the E562. So you can see that it did save it successfully. Now you can also do this if you don't have access through a terminal window. You can do this through your start G-code in your slicer, such as in PrusaSlicer. There are many different ways to do this, and there are lots of documented ways that you can find online to change your Esteps. And finally, in your slicing software, it doesn't matter which one you use, I prefer PrusaSlicer. You're going to need to change a few settings here as well. So retraction, because we went from a Bowden tube setup to a direct drive, we can shorten that retraction. The Bondtech website suggests 0.4 millimeters. I found there was still too much stringing, so I went to 0.6 millimeters, and the retraction speed for that small pancake motor is now 35 millimeters per second, and I also made the de-retraction speed match. At the time of finishing editing this video and posting it to YouTube, I haven't quite made it through a full roll of filament with this new extruder yet, but so far I've found that I haven't had to adjust anything significant in the slicer settings to accommodate the new extruder. It works really well, the prints come off very clean, and even the filament path I haven't changed, so you can see my setup here, and it still runs down through the same filament guide, and there's a link to that in the video description as well, through the original Bowden tube and into the direct drive extruder. Even with using that small pancake motor, I haven't had any issues pulling the filament through this path. No under extrusion to report, so everything's printing really clean and really well. You can see a little bit of stringing in this particular video here, and this is where I bumped up the retraction setting, which I mentioned in the last clip. But other than that, I'm quite happy with it so far, and it's printing great. That's it for this video. Thanks for following along, and don't forget that all of the 3D printable files that you're going to need for this conversion can be found in the video description down below. Please consider liking this video and subscribing, because I put a lot of time and effort into these videos. I would really appreciate it, and I hope to see you guys in another video.